This session, we'll be covering how Tailwind Traders manages their flow of work. Tailwind Traders, they've gone all in on DevOps. They've read about it, they've studied it, they've gone to classes on DevOps. They 100% believe this is but why is this so important? Here's the thing. If you haven't adopted DevOps best practices, your competition, they either have or they will. And when they do, they will out-innovate you. And when that happens, it's game over. You will quickly become obsolete. And none of us wants to be obsolete. Now, this isn't just DevOps theory. We've been doing this long enough now that we have empirical proof. Organizations that adopt DevOps best practices absolutely out-innovate teams that don't. And not just by a little bit, but by a lot. And this is why Tailwind Traders needs to adopt DevOps best practices. But it's not easy to do right. In order to really adopt DevOps best practices, you have to address all three of these pillars: the people, the process, and the products. Now, people, that's a cultural change that has to occur within your organization, where every person from the very, very top all the way down to the bottom must be hyper-focused and aligned on continuously delivering value. For the process, we need a process that will let us iterate fast enough, yet still deliver code of high enough quality. Now, finally, we need products that can help enable all of this. And at Tailwind Traders, they've got the people and the culture down, right? Everyone has been trained, everyone is aligned and believes in DevOps, everyone is prepared to do whatever it takes to continuously deliver value. They've even got their products and tools down, as you saw in the first session. So all they need to do is just figure out their process. Now, in order to continuously deliver value, they need a process that is highly iterative, yet still delivers code of high enough quality. And it needs to be highly iterative because they want to have many frequent small releases versus infrequent large releases. This way, they can continuously deliver value. Now, with many small iterations, they also have the ability to course correct really quickly. Now, we don't always know if what we're doing is what the end users really wants or needs. So if we have a lot of small iterations, we can now make a hypothesis, spend, let's say, 2 weeks implementing it, release it to the public, gather telemetry to see if end users really value this new feature. And if they do, hooray for that. We can double down on features like this or even expand upon this feature. And if they don't, not a big deal, because we've only wasted 2 weeks versus months and months and months of dev time. We will just reprioritize the backlog and then rinse and repeat this process. So what kind of a process will let us do this? Agile and the many flavors of Agile. So things like Scrum, Kanban, Agile with a capital A. Now, personally, I'm a massive fan of Scrum. I love Scrum. I'm a Scrum purist, and I've led several successful dev teams using the Scrum methodology. And I'm not saying any of the other flavors of Agile aren't good, because they're all good, they work. But today, we're going to be looking at Scrum. In Scrum, everything starts with your backlog. And what's a backlog? Think of it as a prioritized wish list of everything you want your software to do. So the most important things are at the top, and the least important things sink to the bottom. Now, at the beginning of a sprint or an iteration, the product owner will go ahead and prioritize that backlog. And then the team will commit to doing part of that backlog based on the priority and what they think they can get done. And then they'll spend the sprint working, they'll burn down whatever bugs are found in sprint, and at the end of the sprint, they'll show what they've accomplished to the product owner in a sprint review meeting, and hopefully they'll push into production as well. And based on the sprint review demo, the product owner then will reprioritize that backlog, and this whole cycle can rinse and repeat itself. So that was a super quick description of Scrum. So let's dive in a little bit deeper and look at some general principles. First of all, this is not a waterfall project. We don't build the entire thing and then release it. We build it up incrementally, so sprint after sprint, building the highest priority items on the backlog first. And we do this because this allows the product owner to look at what we're building at the end of every sprint. And when they do, they can now give immediate feedback. So this here is vital. Most of the time, people don't really know what they want their software to do until they start clicking on the buttons. Because you notice how people are super quick to tell us what they didn't like versus what they want their software to do. So By building our software incrementally, we can now have frequent inspections of our software and immediately course correct as needed. So instead of wasting months of work, the worst that could happen is we waste one iteration and then we course correct. So super powerful, super useful. All right, next in Agile or Scrum, everything should be transparent. The dev team, they're not working in a vacuum. The product and sprint backlogs should be public, where everyone can easily see what the team is currently working on and what the team will most likely work on next. Transparency and communication, again, is another key part in Agile and in a DevOps world. Next, I wanted to touch on what makes up a Scrum team, because there's only 3 roles. First, there's the product owner. There's literally one job for the product owner to do, and that is to prioritize the backlog. The first thing I tell a new product owner is that this is not a waterfall project. Again, we don't ship when everything is finished. In fact, most likely, we won't ever get to a point where everything on the backlog is finished. So hopefully we'll be shipping at the end of every sprint. So we need to make sure that the most important features are prioritized so they get done first. Prioritization, and then the course correction that comes from reprioritizations, that right there, again, another key concept inside of Scrum. Now, in order to be able to prioritize correctly, the product owner has to be able to make decisions on how that product will function and what it will look like. Or said another way, the product owner has to have a vested interest in the end result of this piece of software. The success or failure of this piece of software must directly affect the product owner. Next, there's the Scrum Master. Now, the Scrum Master has 2 roles. First is to make sure the team follows Scrum best practices. And second, is to protect the team, the Scrum team, from outside interference. You ever get that high-level exec that walks up to a dev directly and tells them, I need you to add this feature immediately, right? And of course, this messes up everything from the planning to the scheduling, so on and so forth. It's the job of the Scrum Master to protect their team from people like the high-level exec. They need to be able to tell them, nope, you don't get to do that. You can't drop something on us mid-sprint. Put it on the backlog, you can rank it really high, and we can tackle it next sprint. Finally, there's a dev team. This team, it needs to be cross-functional. When there's someone on your team, you need to have people on your team that can do whatever, whenever that needs to be done for the project. And the more cross-functional your team is, the better it is. Now, I know in an ideal world, every person on the team can pick up any work on the backlog and just get it done. In reality, most people are not 100% full stack, right? But you just need to make sure there are team members that can cover tasks, the different types of tasks. However, we do strive to be cross-functional. So sure, we do each have our own areas of specialty, but don't let that stop us from grabbing tasks, learning, and growing. Let me give you an example. I was once on a project where I finished up all my tasks, and I'm a back-end dev. The only remaining work in the backlog was some crazy SQL query. Now, I do know SQL, but I'm really kind of good enough at it to be really dangerous, right? That's the level that I'm at. So yes, I did pick up that task, but I also pinged my teammate, who is an expert at SQL, and I asked them to pair with me. Because now they can make sure I'm not doing anything crazy or wrong, and I can also learn from them. This will help me ramp me up. It will upskill me on my SQL skills. All right. Finally, these Scrum teams, they should be self-organizing. No one needs to direct a Scrum team on how to do the work, what they need to do, so on and so forth. They can figure that type of stuff out for themselves. All right, writing software, it is like a 3-legged stool. You can have quality, you can have a date you are done, and you can have features. And guess what? You can only move 2 of those things, right? And in a software project, quality is not negotiable. You cannot skimp on quality. So what that means is if you want more features, you must move the delivery date out. And if you can't move the delivery date, you're going to have to reprioritize the features that you're going to ship with. It is that simple, and there are no exceptions to this. Also, when you're planning, estimates, they're not guarantees. And although the more you do it, the better you do get at it. So estimates, they've always been a bit fuzzy, but to help with your estimates, here are my rules. I want to break down all of my work into 4-hour chunks. Why 4 hours? First of all, it's a lot more accurate. I'm pretty good at estimating things within 4 hours. I'm pretty good at estimating even a day's worth of work. 2 days of work? Yeah. More than 2? All right, more than 2, I'm starting to guess. Now, my go-to estimate, if you ask me how long it will take to do something, I'm always going to say 2 weeks. Why 2 weeks? Because I think I can write just about anything in 2 weeks. I can probably write an entire OS in 2 weeks. But to be really accurate, I'm only good to about a day or two. And I've been doing this for over 20 years. All right, so next, if we break down a user story into 4-hour chunks, there's now a possibility that instead of just one person spending 3 days working on this can be split up into a lot of small tasks, and my team can work on it in parallel, which means we can potentially knock this user story out much faster. Also, with much finer grained tasks, it is so much easier to track progress. So if I just have a task that's 2 weeks long, when I look at my board, how do I know work is progressing, right? Because we've all done this, where on day 1, we can say, hey, we're 20% done. And after day 2, we can say, hey, now we're 60% done. And then on day 3, we're at 90% done. And for the rest of the 2 weeks, it just stays at 90% done. And at the end of the sprint, we're still not done. So if you break down your tasks into 4-hour chunks, this lets us plan and track work so much better. And finally, never start from a date, right? Because developers, we're pleasers. We want to make people happy. So if you start from a date, we're going to magically subdivide the work up so they'll fit in the allotted time. Even though this doesn't work and it's not accurate, it's kind of what we do. So don't start from a date. Work out the task, break it down into 4-hour chunks, and then see where the end date lands. Finally, the rules apply to everyone. In order for Agile to work, everyone in the organization must be hyper-focused and aligned. So remember, the whole point of us moving away from Waterfall to Agile is we finally admitted that Waterfall does not work well for software projects. In fact, 90% of Waterfall software projects flat out fail. And by fail, I mean they go over budget, over time, too many bugs, or the end result is not what the end users want. So we know the old metrics and the way of doing things is garbage. We must all be aligned now with how things are done and measured in an Agile world. Everyone from the very, very top all the way down to the bottom. And no one is exempt from the rules, no matter what their title is. Okay, so Tailwind Traders, they get Agile. They get Scrum. But to do Scrum right, they need tools that will help them track their work from sprint to sprint to sprint. They need to be able to easily reprioritize work on the backlog, as well as track their work both within a sprint and across sprints. And all of this needs to be easily accessible by everyone, because remember, no one is working in a vacuum, right? The product backlog, the sprint backlog, the current product plan, those need to be publicly available. And guess what? Azure Boards, linked to my GitHub repo, does a great job of this. So let's check this out. In the world of Agile or Scrum, everything starts from the backlog. So here's my backlog, and as you can see, it's an ordered list of everything that I want my software to do. Adding new work, I can just click the new work button, I can give it a title, add to the top, and there it is. Now if I click on this particular work item, it opens up a form and I can give more details. So I can give things like descriptions, acceptance criteria, etc., etc. Now, if I want to prioritize my backlog, that's as simple as just dragging and dropping on this board. Now, the other thing people use the backlog for is they choose the work from the backlog and say, this is what I want to do for a particular sprint. So they create a sprint backlog. In creating, that's easy enough. I can just go ahead and multi-select, and then I can just drag it and drop it to the sprint that I want. And if I click on the sprint, it will take me to my sprint backlog. Now my sprint backlog behaves exactly the way I expect it should. You can now prioritize work by dragging and dropping. I can add new work as well. And the other thing it can do is I can break down my work into the individual tasks that I need to complete this item. So again, tasks, remember, they should be 4-hour chunks, right? So for this particular work item, let's say I need to update my database schema here. And I also, let's break this down a little bit more. Let's say I need to update my API layer. Awesome. So pretty cool, right? Now I have my work item. I've broken it down into 2 individual tasks. I love backlogs, both the product backlog and the sprint backlog. They're great at adding and prioritizing work and doing breakdowns. But where they start falling down is tracking work as it's happening. Now I want to be able to track my work as it happens, and I want to be able to do this visually, both within my sprint and across sprints. And you can totally do this with Azure boards. So the first thing that we're going to check out is the task board. So here it is. Here you can track what your team is doing within a sprint in a visual manner. You can drag it and drop it and you can see what's going on. Super, super cool. Now if we zoom back out a little bit, we can see at a higher level what a team is doing from the Kanban board. So this is a fully customizable Kanban board that shows the ongoing state of my project. And I really love this board because now in one place I can easily see what's going on in my project. I can also see when a work gets stalled in a particular column, and when I notice that, I can now redirect my team. We can swarm on that particular unit of work. There's also deep integration between the work items created in Azure boards and also with GitHub. So let's go check out this deep integration between the 2 systems. So let's bring up GitHub. And if I make some changes to my file, all I need to do is format my commit message in a certain way. So let's pretend I'm doing work for work item number, how about work item number 425, all right? So in my commit message, I just need to say, let's say doing some stuff, this is where the magic happens, fixes AB pound 425. Now, check out what happens when I click the commit buttons. Look at the board and bam, did you see that? How cool is that, right? The work item magically flew over to the done column because of that deep integration with GitHub. But wait, there's even more than just that. Let's take a look at this work item. This work item is now linked to the specific commit in GitHub. If we click on this, it's a deep link into GitHub that will take us directly to our comment or our commit. And now we can see exactly what we did in the GitHub UI. Super, super cool. This deep integration between Azure boards and GitHub makes working really, really nice. Okay, Tailwind Traders, they're now almost ready to start diving into code, but they still have one process question, which is what branching scheme do they want to use? Now, traditional branching schemes involves a lot of long-living branches. So you've got dev branches, QA branches, feature branches, UAT, main, etc., etc. And having all these long-living branches, it's not conducive to moving quickly. Like anytime you need to merge code from one long-term branch to another, boom, a merge bomb goes off. And guess what? Sooner or later, you're going to get a code conflict. And fixing these merge conflicts is not easy or pleasant or quick to do, right? This is extremely painful and an expensive problem that everyone will run into if they use long-running branches. So to solve this problem, Tailwind Traders, they've decided to use trunk-based development, where they're basically deving and releasing right off the main branch. So the way they do this is when a dev picks up a user story, they create a topic branch, do their initial work, and they very quickly merge that topic branch back into the main branch. With no long-running branches, there's almost no merge bombs. And any conflicts that do exist, they can be solved really, really quickly. So easy peasy, right? Problem solved. But some of you might be thinking, how can this possibly work, right? If you're practically deving off the main branch, how are they not just introducing bugs all over the place? They solve that problem by using a software technique called feature flags, or feature toggles or switches. So feature flags is a technique that lets you turn on or off certain portions of your code during runtime. In one deployment, you can now ship alternate code paths. And during runtime, you can pick which path you want to go. So this is awesome because what that means is you've now separated deployment of your code from the delivery of your new features. So this starts making things super, super flexible. Because of that, every new feature and every new bug fix Tailwind Traders writes, it must be wrapped in one of these flags. So now they can check into master without fear. As long as a flag is off, the new code does not get run, only the old code. All right, from a code perspective, there really isn't anything magic with feature flags. They're glorified if statements. Wait, actually check that. They're not glorified if statements. They are literally if statements. They really are super easy to implement. So I've come across a lot of companies when I tell them about feature flags, they'll be like, oh, feature flags, it looks really cool, right? But we're not ready to use feature flags. Our application isn't architected in a way to support feature flags. That's just ludicrous, because if your architecture supports an if statement, guess what? Your app, it's ready to use feature flags. And once you start using feature flags, you can now start doing some really cool advanced DevOps stuff. For instance, you can do things like A/B testing, where a percentage of your traffic runs in variation A and a percentage of your traffic runs in variation B. And now you can grab the telemetry and figure out which one is delivering more value, right? Very powerful. You can also use feature flags to do something called safe deployment, where you only turn on the flag for a really small percentage of your traffic. And you make sure everything still looks good and works for just that small percentage of your traffic. And then you can open up your flag a little bit more and make sure that works, and open it a little bit more until you're very sure everything is good, and then you can turn it on for your entire traffic. Finally, another thing you can do with feature flags that's super cool is if something goes wrong with your latest deployment, rollbacks become super easy. All you got to do is just turn off your flag and voila, you're done. The new feature, that's what rolling out is. That's all it takes. All right, so enough talking about feature flags. Let's see them in action. So what you're looking at is my resource group in Azure that holds the resources for this particular project. And one of the resources is going to be an app configuration. Right? So this will hold all the configuration for my application, including my feature flags. So to look at my flags, we'll go to feature management, and notice I have one feature flag right now, and it's called the new about flag, and it's currently in the off position. So if we jump to my application and we refresh this, okay, here it is. Look at across the top, there's an about tab, and it just says about. If I click into it, that's my current about page. Hooray for that. All right, let's jump back to the portal, and we're going to turn on our particular flag. So here's our portal. We'll turn on the flag. That's all it takes. Now let's jump back to the application, and we'll refresh. And now check out the about. Instead of about, it now says new about. And if we click it, it takes us to the new about page. Pretty cool, right? All right, so as you can see, these feature toggles, really easy enough to toggle it on and off while your website is running. So you can also do this programmatically as well, turning the flags on and off using the CLI. Now to implement, super easy to do as well. So let me show you. Here's my code. You can implement your flags both in the view and also the code. So let's check out the view first. This right here is your standard .NET view. You can add a feature flag by adding this tag, the feature tag, with the name of your feature, and with negate is equal to true right here. What that means is if the flag is off, then go ahead and output this chunk of HTML. Otherwise, if the flag is on, the new about flag is on, output this chunk of HTML. So what this is saying is if the flag is off, just output about, and if the flag is on, you output the new about, right? That's what we saw. All right, so in my code, this is how you would implement it in code. So I'm using .NET, and these flags are supported in a bunch of different languages. You can do this in two ways. First is by adding this annotation to an action in your controller. So if the flag is on, this action, it will exist. And if the flag is off, this action, it won't even exist. You can also do this inline with the if statement. So here I can say if, and I use a feature manager object, if it's enabled, and I pass in the feature flag that I'm checking, and if that flag is enabled, go ahead and run this chunk of code inside the if statement. And if the flag is off, you do the else, right? All right, so to see this running, let's set a breakpoint, and we'll go back to the app, and we'll go ahead and trigger this. So let's jump to the home page, click on New About, and it will hit our breakpoint. Hooray for that. And now, when we walk over this if statement is going to evaluate, And you'll see that the flag is on, so it goes into the if statement and runs this chunk of code. Now, when we jump into the view, this is my about view. And if the feature is on, it's going to go ahead and output this chunk of code. And if the feature is off, like negate is equal to true, right, it's going to output this chunk of HTML. And if the feature is on, it's going to output this chunk of HTML. So, feature flags, they're super powerful and they're super easy to implement, both in your code and also up in Azure as well. All right, finally, Tailwind Traders, they've got one thing that they're worried about, and that's quality. So moving as quickly as they will be moving, they're not going to have time to do full end-to-end functional testing. So they need to shift left and build quality into their app as they're writing it versus trying to tack on quality at the end, like the way traditional software is QA'd. So one of the things they did to improve quality is they're requiring every check-in to go through a pull request or a code review. However, they quickly ran into some problems with their pull request workflow. First, pull requests were getting lost in the shuffle. People would either miss or ignore pull requests and they would start piling up. Now, there are some amazing benefits with pull requests. But if you don't do them immediately and they start piling up like this, your dev work comes to a grinding stop. Now, another problem they had when reviewing the code changes in a PR is that they really wanted to see the changes running in a live test system. But that's a lot of work, because what that meant is for each PR, they'd have to build the app, package it up, provision the infrastructure they needed, configure it correctly, then they needed to deploy the app into the freshly provisioned infrastructure. And now they can finally see those changes. And oh, when they were done with the PR, they really kind of need to clean up the staging environment too, right? Because otherwise they're just going to leave a giant mess. And that sounds pretty crazy. Like being able to do this for each PR, it would be awesome. But really trying to execute this would be a serious pain. I mean, who has the time or energy to be able to do this correctly every single time and to do it quickly? And that's where GitHub Actions comes to the rescue. So Actions, that's GitHub's workflow engine, where you can automate all sorts of things inside of GitHub. Just as an example, I created automation using Actions to help take care of Tailwind Traders' pull request problems. So to solve the problem of PRs stacking up with no one really knowing PRs are there or waiting for them, what I did was I created a swim lane in our Kanban board, and I called this pull requests. And now whenever there's a pull request, I'll have GitHub Actions automatically create a pull request work item, link it to the GitHub pull request, and I'll put it into the Kanban board into the correct swim lane and the column, right? So this way, it is readily apparent there are PRs waiting to be looked at, and if no one picks it up quickly, as the Scrum Master, I can jump down my team's throat until someone finally does it. But wait, there's more, right? Next, I'll have this action automatically build and package up my application. And then, since I'm using Azure App Service to host my app, I'll dynamically create a staging slot named after my pull request ID, where I then deploy my application. And then, since the URL to my staging slot is dynamic and changes for each PR, I use Actions to write back to my pull request with a link to my staging environment for this specific PR. So this makes it super convenient for the person reviewing the pull request. And finally, when the PR is closed, I'll be a good citizen and my action will go up, clean up, and delete the slot from Azure App Service. So this sounds kind of nuts, right? But we can totally do it. Let's check it out. So what you're looking at right now is all the resources for this specific application up in Azure. One of the resources is the app service hosting this application. So if we go ahead and look at the deployment slots for this specific application, we'll be able to see that I have one slot right now specifically for production. All right, let's jump into the Kanban board. And you can see that it's configured exactly the way Tailwind Traders want. So they have an emergency swim lane for live site incidences. So again, this way it's super easy for them to see. The team can swarm on live site incidences and they can fix it. It's very visual, front and center. they also have a swim lane specifically for pull requests. So again, they were having trouble seeing when pull requests happen, and pull requests were getting lost in the shuffle. So this way, it's really easy to see. It's on their board, front and center. Team members can see it and jump on and start doing their PR. The rest of the board is configured exactly the way Tailwind Traders wants it. And okay, so let's go ahead and create a pull request, and we'll make some code changes. So let's pretend this work that we're doing is for work item number 432. And instead of checking in directly, we'll create a branch, and then we'll go ahead and create a pull request. And as soon as I create that pull request, it's going to go off and kick off that automation that I have. So let's jump into the Actions tab, and we'll see the automation happen in real time. So here we are, automation's been kicked off, and now we can see in parallel, we're creating a new pull request work item inside of Azure Boards, putting it in the right place. Bam, did you see it? There it is. And we're also going to, in parallel, build my application, right? So when it's done building, it will then provision a new slot in my app service, and then it will deploy that newly built app into the provision slot. So this takes a little bit of time to do, so while this is running, let me show you how I configured all of this. Now, the automation is using GitHub Actions, and the way you set that up is off of your root directory, you're going to have a .github/workflows directory. And here's where you store the definitions of your workflows. And you're going to store it as YAML files. And I know nobody really loves YAML, but this one's pretty easy to understand. So first, you're going to name your workflow. So it's called name. And next is the on section. That's going to be your triggers. So I have two triggers. One of them is for pull requests. So anytime somebody issues a pull request to the master branch for open, synchronize, reopened, or close, it will go ahead and trigger this specific workflow. There's also another trigger called workflow dispatch, and this is just a manual trigger that I trigger from the UI. So I can use this to help me debug this workflow. The next section is my jobs, right? So the first job that I have is let's go ahead and create my pull request work item inside of Azure Board. So that's what it does. Next, in parallel, I build my application. So I restore my packages from NuGet, I build my app, package everything up, I upload that package as a zip file back up to GitHub. Hooray for that, right? It's just a normal build. And now for my deploy stage, this is not going to run in parallel, right? Because I need to wait for the build to actually finish. So right here where it says needs build, that's where I'm saying wait until the build is finished, then go ahead and do your tasks. So what is this one doing? It's going to download my build artifacts. Then it's going to go ahead and get my pull request values from GitHub. So things like the title and the ID. And then I'm going to use the Azure CLI. So first I log into the Azure CLI. And then using the Azure CLI, I can create a deployment slot that's based off of the pull request ID. And when that's done, I can deploy my app into that specific slot. And when that's done, that's when I can go and create a comment into my pull request. So that's what I'm doing here. I create a comment back into the pull request into GitHub, and I give it the unique URL to the dynamically created slot. All right, and when I finally close this pull request, it's going to go ahead and clean everything up by deleting the correct slot. So it does that by getting my pull request values, then using the Azure CLI, I go ahead and delete what I need. All right, so let's go back to my actions, and we can see that it looks like it's completed. Everything is green, that's good. So now let's jump back to the browser, and we'll go ahead and check out what really happened in our environment. All right, so first let's go back to the portal, and we can see, let's refresh this, and bam, there's a new staging slot with the ID of the pull request. All right, so now if we go back to our Kanban board, we'll be able to see that it's created a new work item, right? And if we click on this, this will take us into the work item. And this is super cool because you can see that there's a link, there's a deep link back into GitHub. So this links us back to the GitHub pull request where now you can see it's adding a brand new comment. So we can click on it and we'll see, dun dun dun, we added a new comment that says created staging environment with a URL to my staging environment. So this makes it really easy for whoever is doing my PR. Now if I click on this link, bam, it takes me to my app running in my staging environment just like that. How cool is that? All right, so not only does it do all of this, it does clean up, right? So if I go ahead and close this particular pull request, let's check out what should happen. It should clean up my staging environment, right? But again, automation is going to kick off, so we'll jump into actions. And you can see there it did. Automation is kicked off. And if we drill into it, we can see that it's now closing my pull request and cleaning up my staging slot. And it does that by deleting the correct staging slot from my Azure App Service. Again, this takes a little bit of time to do, so we'll go ahead and wait until it's done. All right, it's done. So now if we go back to the Azure portal, let's refresh this, and voila, the staging slot has now been cleaned up. Very, very cool stuff. Okay, so what I wanted to demonstrate with this specific demo is that I wanted to show that we can create a very intricate and complex workflow using GitHub Actions. And because Actions is so flexible, you really can make these workflows do just about anything, not just CI/CD. So go ahead, go and create automations to help enable your workflows. So this is super cool, man. Tailwind Traders, they're now in a really good state. They have adopted the DevOps mindset. They've picked the products that will help enable DevOps, and they've implemented processes that will be doing what they need to do, right? So they've got everything now. They have the culture, the people, they have the process, and they have the tooling. So now the fundamentals, they are all in place, and they're now ready for some more advanced topics. So join us in our next session, Delivering Change in the Cloud, and we're going to dive into ways Tailwind Traders can deploy into the cloud both faster yet safer. So we covered a lot today, so let's do a quick recap. At a high level, we covered how Tailwind Traders will be running their projects using Agile and the Scrum methodologies. And Tailwind Traders, they're going to be using trunk-based development with feature flags to be able to move at DevOps speed. And finally, using GitHub Actions as an automation engine, they've automated a fairly complex pull request workflow to help them move quicker yet safer. Now, if you would like to take a deeper look into all these DevOps concepts and more, head over to aka.ms/allthingsdevops, where you're going to find our DevOps Resource Center. Also, to get certified with AZ400 certification, head on over to aka.ms/AZ400cert. And to prep for the exam and to learn all the DevOps techniques in AZ400, head on over to aka.ms/gettingstarteddevops. And we're going to be talking about a part of DevOps, which is delivering change to the cloud. Now, Tailwind Traders, it's an online hardware store, and their software delivery team and engineers, they've been getting much better at working as a team. They collaborate well using Microsoft Teams, and they consider security really early on in their process. And they even have continuous integration that runs all of their tests and ensures the quality of their code every time they check their code in. But when they make changes to their application, actually delivering it to customers, the deploying to production part, that's still really manual, and it gets delayed because it's really hard and it's super, super painful, right? It hurts every time they deploy because things break. So naturally, they start avoiding deployments. And after a bit, when they absolutely have to deploy, what was just one small change has now become lots and lots of changes, which of course just makes everything that much worse. And when the team finally does deploy, is all that work going to be worth it? And we really don't know until it's in the hands of our end users, right? Because we can spend a lot of time coding up features, and when it finally does deploy, our end users could be like, yeah, didn't really like that feature. And now we've just wasted all that time because now we've delivered zero value. So it's much better to fail fast and then course correct. Spend a small chunk of time writing code, quickly deploy, get feedback and telemetry from our customers, and if we are delivering value, that's awesome. Carry on, right? We can flesh out this particular feature. And if not, we can quickly course correct. So this works with DevOps perfectly because DevOps ultimately is the union of people, process, and products to enable the continuous delivery of value to our end users. So this is Microsoft's definition of DevOps, and value is the most important part. The earlier you can put something in the hands of your users, the sooner they can evaluate it and see if it's true value. Deploying every 12 months, that's not going to cut it, right? That's not going to give you the agility to change directions quickly. And we as an industry have learned that we're really bad at guessing what our end users want or need. We only really know when the feature is in the hands of our end users, either by directly giving us feedback or through telemetry. And that's why we constantly talk about continuous delivery. Right? So in getting started with DevOps session, that first one, we looked at collaborating effectively. And then in managing the flow of work, we improved how our work goes from start to finish. But so far, we haven't really talked about delivering anything to the end users, and that's what we'll be looking at in this session. CI and CD, those are terms that are thrown around a lot, but they don't always mean the same to everyone, so let's go ahead and level set. CI is continuous integration, and CD is continuous delivery, or it could mean continuous deployment. CI is continuous integration, and it's all about ensuring your changes work with everyone else's changes. Or said another way, your changes need to integrate with everyone else's change. So whenever you do commit, a build should happen to ensure at the very least the changes you made still build with everyone else's code. Next, tests should run, right? Because you want to maintain your quality from one check-in to the next. So we try to catch our bugs as early on in the dev cycle as possible. But wait, there's more, right? There's more to it than just building and testing. Ideally, anything else you care about when it comes to building your app should happen here. So things like linting or security auditing or maybe even scans for credential leaks or whatever else you need, they can happen right here. So depending on what you're talking about, CD could be continuous delivery or continuous deployment. Continuous delivery means at the end of each automated CI/CD pipeline, you have a deployable application or a deployable piece of work, a deployable unit, and you can pick that up and deploy it at any time. So this should include scriptable environments as well, for instance, like infrastructure as code, where even if no environments are provisioned, or if someone manually went in and configured your infrastructure incorrectly, you have everything you need to stand up your application correctly at the end of this pipeline. Continuous deployment, that takes it one step further, and it actually deploys. So it may not necessarily deploy it into production. You might have CD into a test environment or a staging server with gates where you can promote this into production, right? But ultimately, continuous deployment is all about when you go to deploy your application, your pipeline is trustworthy and reproducible. You know the deployment into production is going to work because you did your deployments exactly the same way to your other environments. So my pro tip is always have continuous deployment to somewhere. Don't assume the version you just created is going to deploy as cleanly as the last version. So always deploy somewhere. All right, so let's talk a little bit about GitHub Actions. We've seen actions in some of the previous sessions. We've even seen examples of complex workflows around continuous integration. But we haven't really looked at continuous deployment with GitHub Actions. Now, we've seen actions can build our software, but what about deploying into production? So first of all, GitHub is an automation engine for any workflow related to your repository. And yes, we've been using it for CI/CD, but that's only one way to use it. You can run a workflow when someone comments on an issue, or when someone forks your repo, or even just on a regular schedule. In fact, there are dozens of different events that can trigger this workflow. However, it is very good at CI/CD, and it can deploy almost anything to almost anywhere. All right, so let's look at Tailwind Traders again. Tailwind Traders is a hardware supply company, and they want to make some changes to their application. So we're going to go through a CI workflow, and then we'll extend it to take it a bit further to deploy it all the way out to Azure. All right, so this is the Tailwind Traders website, and the marketing team has told us this recommended here, not descriptive enough. They want us to change it to recommended categories. All right, easy enough fix. We'll jump into VS Code. We can change our translation file, and we can make the change here. All right, so after we make the change, we'll go ahead and save this and we'll check our code in. So this is just git commands. We'll do a git commit and then we'll push this back up to GitHub. Now, as soon as our code hits GitHub, it's going to trigger our workflow. And our workflow is defined in this specific YAML file. So as you can see, anytime code hits main, it's going to trigger this workflow. And this is just going to go ahead and build our application and then run our tests. So if we come into the Actions tab in GitHub, we can see this workflow has been kicked off. We can drill into it. And we can see, yes, all it's doing is it's going to build our application and test it. It is not doing any deploying of any type at all. So let's go ahead and jump back into our workflow definition, and we'll add some actions that will do that deployment. So the first thing we're going to do is at the very end of this workflow file, we're going to add some actions to do some deployment steps. Right. So the first thing we're going to do is we're going to add a .NET publish step. And this will create my deployable artifact as a zip file. So it's going to be my web app all packaged up and ready to be deployed. All right, so after this publish step, we're going to add another step that's going to deploy the packaged web app to Azure App Service. So notice we're going to pass in the publishing profile of this app service as a secret, right? So we need this to be able to deploy. And we're also going, let's add one more task in between this. I want to be able to upload my build artifact to this specific release because potentially I want to do something with this build artifact later on in this workflow, maybe like in another job, right? All right, so we've added that. We'll go ahead and save our changes and we'll go ahead and commit these changes back up to GitHub. So again, this is just your normal GitHub workflow. We'll do a commit and then we'll push. And once we push our changes up to GitHub, once the code hits GitHub, it's going to trigger our action. And let's jump into GitHub and see what it's doing. All right, so here's our action. It hasn't started yet. Let's click on Actions again. And there it is. Awesome. Our action is running. We can click on it and we can see in real time everything that it's doing. So this takes a little bit longer to run because not only are we building and testing our application, we're also deploying as well. So as this is running, let's talk about some of the other options you can do inside of your build. So GitHub Packages is super useful if you are creating a reusable package that you want someone to download and use later. So things like Docker containers or NPM or NuGet packages, right? This is a great package management system, easy enough to use and add into your workflow. Another thing you can do with your build artifacts is you can upload it to a specific release. So this will allow you to upload your artifacts to a specific release as a downloadable artifact. And you can do that inside of your GitHub Actions workflow. And then you can download and use the artifact later on in your workflow, like for instance, in another job somewhere. So here's an example of how you can do that. All right, in terms of deploying to Azure, there's all sorts of things that you can do with Azure as well. You go to the marketplace, search for Azure, and you're going to find piles of actions of things you can do inside of Azure. What's really cool is all of these actions, the ones written by Microsoft, they're open source. So the source code is checked into GitHub, and you can read the code to see what they're doing, or you can even submit pull requests if you want to add features or to fix things. There's also a lot of documentations around how to use these actions. But one of the best pieces of documentation is examples on how to use these actions in real YAML files. So if we go ahead, let's go ahead and scroll down over here and click on Azure Starter Templates. Here you'll see plenty of examples of workflow templates that actually use real Azure actions. And if we click on Azure App Service, now we're going to see a bunch of workflow definitions as YAML files for Azure App Service. So if you're going to do something, we probably have a sample that we can use. All right, jumping back to the build, we can see this process. It's almost complete. We've built our app, we've uploaded our artifact, and now we've deployed our application as well. So if we look at artifacts, bam, there we go. We've really deployed or uploaded our artifacts back up to this specific deployment. All right, so now if we jump into production, we should see our changes, right? So let's refresh this, and instead of recommended, bam, it says recommended categories. Our change has now been pushed all the way out into production. So all we needed to do was check our code into source control, and automatically those changes were built tested, and deployed into production. And that's great, right? But maybe we want to deploy this same app to lots of different environments, maybe even hosted in different places, like maybe hosted in Azure and also in our own data center, or maybe even in someone else's cloud. So guess what? Containers, they're a great way to do things like that. So we're going to remove all of this and we're going to replace this with Docker commands. So what are we doing? We're going to build our application in a container, then we're going to containerize our application, then we're going to upload our container image into a container registry. So let's go ahead and do a commit, and we'll push these changes back into GitHub. Now, once we do that, that's going to, of course, going to kick off our action, our workflow, and it's going to run using this definition. So what is it doing? It's doing something pretty simple, right? It's going to go ahead and build our app in a container. It's going to create our application in a container. It's going to create an image for that, and it's going to upload our container image to a container registry. So let's jump into the Azure portal. We can look at our container registry. You can see we already have some container images here. That's awesome. And now if we jump back to the workflow, as soon as it's finished, that means it's uploaded our container image up to our container registry. So jumping up back into our portal, this is our container registry. Let's refresh this. And now you can see our workflow added a new image to this repo. Now we've tagged our images with latest, if it's the latest build image, and also with the SHA from GitHub. So everything is super traceable. And we also have an Azure App Service that's connected to this, and it's pulling images from this registry. In fact, every time there's a new latest tagged Docker image, it will automatically pull it down and deploy that Docker image into production. So bam, there's our code running up in production, just like that. So this is a super cool way, a super cool workflow of getting our code into production by using containers and container registries and hooking Azure App Service up to our container registry. Okay, so we've seen a couple different examples of pushing to production, but we probably don't want every one of our changes to go straight into production. Now, if we follow trunk-based development practices, working mainly off of trunk, then any commit to main branch, that's going to deploy to production, right? But we don't want that, at least not initially. We want some opportunity to verify that our changes look good and it doesn't break anything. So what are we going to do about it? We've spoken in other sessions about working with pull requests to make sure there's an opportunity to check any new code before it gets merged into the main branch. And as I've mentioned, there are dozens of events that can trigger workflows, and pull request is one of them. So now during a pull request, we can build that app, test that app, then we can deploy that app into a staging environment that's specific for that pull request. So now we can test the outcome of our changes before it's merged into the main branch. Or in other words, we're applying checks before merging back into the main branch. So there are quite a few trunk-based pull request workflows that work really well. But here's one that I really like. So this blue line here represents our trunk or our main branch. And as work gets done, a short-lived feature branch is spawned and work is done in there. So these short-lived feature branches, they represent the work we are doing, and it's important that they are short-lived. We don't want these branches to live for a long time. We don't want a month's worth of work stacking up inside these branches, because that's when merge bombs happen. So we're really talking about days here, max. Now, when we are ready to release or deploy something to production, we can create a release branch off of the main branch, and this will be used to deploy our code. And you can do the same thing with tags or with the releases. I really like using branches because branches are super cheap in Git, and it's also a nice way to archive everything that changes. And also, if we need to do hot fixes, we already have that branch ready to go. All right, let's take a look at pull request workflow in these short-lived branches. When we do a pull request, we can run a workflow, and at the end of that, we can deploy our application into a separate environment for each and every one of these feature branches. Now, with these short-lived branches, we can merge them into the main branch. And then we can have workflow that will go ahead and build and deploy from our main branch. So this automation means all we need to do is submit a pull request, and the newly running code that is tested on is then deployed. And when you do a merge into master, you get the running application in a certain location as well. But that main branch, what does that mean? Does that mean it will go into production every single time? So that is one option, but you never know for sure if the merge is going to work exactly as planned. And more importantly, you don't know if that merge will provide the value to your end users, which is what DevOps is all about. So what we really want to do is test our changes before we go into production. So one way to do that is we can pick these deployments off of main that work and promote them to the production environment. So our main branch doesn't deploy to production, it goes to some staging environment first, and when we decide this specific release should go to production, we can release that. We can create a release branch and promote that specific change all the way out to production. Now, there's a number of ways to do trunk-based development, and all of them have their pros and cons, and this just happens to be one that I like. There's also a lot of different ways to promote these deployments into production. The important thing is you should be deploying the exact same artifacts from one environment to the next, right? So I said this carefully. Make sure you listen to what I say. You shouldn't have to rebuild. We really need to use the exact same binaries that we deployed in our staging environment and promote those exact same binaries into production. All right, so yes, there are a lot of ways to do this promotion. But one super cool way that I want to show you all is using a technique called ChatOps. ChatOps is using your chat application, whatever that may be, to control your deployments in a nice way that keeps you in the tool that you're using in your collaboration. So next, we're going to implement ChatOps. We'll use GitHub Actions, since our code lives in GitHubs, and we'll deploy using Azure App Service, since our app is hosted in Azure App Service. And of course, we're going to use Microsoft Teams as our chatting app. And as we saw in the Getting Started with DevOps session, Microsoft Teams is an amazing collaboration hub for Tailwind Traders. And we can add even more collaboration features into it by implementing ChatOps through Microsoft Teams. So first, let's look at how we can implement something like this with Azure App Service. Now, App Service has this really cool feature called deployment slots. You can think of deployment slots a bit like a shadow version of your app. So it shares an app service plan, but it's a completely new instance of your front end. But you can direct some traffic to it. So it's a great way to deploy your application because it's essentially you're deploying into production, but it gives you a chance to test things out before pushing it live to all of your users. Now, initially, maybe you have 100% of your traffic going to the production slot and you deployed into the staging slot. Then you can test out the staging slot, and when you think everything looks good, that's when you can swap those slots around. So now all the traffic is now being redirected into your staging slot, and what was your production, that can now be your new staging slot. So this is a really nice way to implement a blue-green environment. And swapping slots is super easy too. You can do that from the Azure Portal UI, or you can use the Azure CLI. Another thing you can do is direct some of your traffic to the staging slot. And this will allow you to test it and let some of your users see the new code just to make sure everything is okay. And if it's not, only a small portion of your traffic saw that bad code. And it's easy enough to swap that out, right? So next, you can slowly, if everything's working, you can slowly open that up traffic to more traffic and then to more traffic until eventually 100% of your traffic is now using that new slot. So something like this is you can use for canary deployments, or this is also like doing safe deployments. And using slot is a great way to implement this. You can also implement this in different ways, like using feature flags, but slots, super powerful. You can totally do canary deployments and also safe deployments. But how are we going to trigger this swapping, right? We're going to do that inside of Microsoft Teams. As we saw in Getting Started with DevOps, Microsoft Teams is a great hub for team collaboration. It's not just for chat, and it's not just for calls and sharing documents. There are lots of extensibility points that allow you to really use it as your hub for anything project related. Now, there are piles of wonderful stuff available with conversational bots, with customizable tabs, messaging extensions, so on and so forth. But for our purposes, we're going to be talking about connectors and webhooks because that's what we need to really integrate with GitHub and Azure to help with our delivery, our software delivery. And now we can do all of this without leaving Microsoft Teams. Also, we'll be using a cool features inside of Teams. Instead of just dumping messages in the channels, we're going to use something called an adaptive card. So these can give you powerful interactive containers so you can actually do work and make things happen rather than just see status updates. All right, so here's the plan. When a PR is merged into the main branch, this is going to kick off automation and will deploy the build to a staging slot. Next, GitHub will go ahead and send a message to teams that a new deployment just occurred using an adaptive card. And this will say a new deployment occurred. It will have links to the new staging slots, and we'll have a button that will promote your changes into production. So after seeing this message in Teams, you can go directly to the staging slot, test everything out, make sure everything looks good, and if it does, then we can click that promote button, and this will trigger the promotion or the slot swap, and then the staging deployment will be promoted to production. All right, super cool. Let's take a look at this in action. We'll walk through this workflow using Tailwind Traders' website. Again, we need to make some changes, but this time we'll be a little more safe with our deployments. We'll deploy into a staging environment, test it out, and then promote those changes into a production environment. In fact, we're going to take this one step further and go through a pull request first. So here's our website again, and this time the finance department came to us that this free shipping that we're doing, that's not going to fly, man. It's costing us too much money. So instead of free shipping, they want us to change it to cheap shipping. All right, easy enough. I've made those changes already, and if we jump into VS Code, we can see some of the changes that I've made. And I've made these changes in the cheap shipping branch. And when I checked this branch in and issued a pull request, this kicked off my automation, which built this branch and then deployed it into staging. So this is my production branch, and as you can see, the changes did not deploy to production. It deployed to my staging pull request site first. So here you can see in our Teams channel, GitHub alerted us to the pull request. And that came from the GitHub Enterprise connector. So here's where we configure our connectors, and we configured this to send events from GitHub, our project in GitHub, to this specific channel. All right, so now, if we click on the View in GitHub button, this will allow us to view the pull request directly in GitHub. And here we can see exactly what changed, and in this case, we changed free shipping to cheap shipping. All right, we can also see this build kicked off our pull request build workflow. So clicking on the details, we can see exactly what happened in this workflow. Now, part of this workflow, it deploys this to a pull request staging environment. And what we want to do is check that out, make sure it looks good, and see if this is something we want to promote to production. All right, so let's go ahead and jump to our pull request staging slot. We'll go ahead and refresh this. And free shipping then changes to cheap shipping. Yay! Our changes hit our pull request slot. It looks good. So what we want to do now is merge these changes into the main branch. So let's just jump back into Teams, because now we can go directly to our pull request, and we'll merge this to our main branch. All right, so once we merge our changes, it's going to, of course, kick off our actions. And here we can see that it kicked off. And now we can jump in here and we can watch it run through. All right. There's an extra step configured now where we send a message to Microsoft Teams. So yes, it builds, it tests, it publishes, it deploys it, but it also sends a message to Microsoft Teams. So what that's doing is we're sending a message from here, hitting a webhook in Teams, and it's sending an adaptive card to our ChatOps channel. So if we jump into the ChatOps channel, we can see that adaptive card where it says deployment has completed. And there's also a deep link to the commit which triggered this automation. And if we click on this, it will take us directly to that commit in GitHub, which shows us exactly what was changed. Now, going back to that adaptive card, we can click on the open staging site, and this will take us directly to the staging slot. And you can see cheap shipping has made it to staging. Awesome. But it still hasn't made it to production yet, right? Hasn't made it to production. So now we can jump into the Azure portal, and in theory, we can just swap the slots here, right? But jumping around in different tools is kind of a pain. Plus in Teams, we have that adaptive card, where if we press that Promote to Production button, if we click it, it's going to hit an Azure function, and in the background, it's going to use the Azure CLI to swap slots. And now we get an updated card that tells us the application was promoted to production, with a button to see the production site. So let's go ahead and click it. This will take us to production, and now we can see, let's refresh this, instead of free shipping, it's now cheap shipping. It's made it all the way into production. Hooray for that. So we're looking pretty good now. We have continuous integration. We have continuous deployment workflow. And it's using GitHub Actions, Microsoft Teams, and the power of Azure to make sure we're deploying our application out to Azure. But our production environment is now protected, and we have an opportunity to check it out in a staging environment before we promote those changes to production. All right, one thing we pointed out a bit in these demos is the idea of keys, secrets, and credentials, right? When you deploy your application, there are places you're going to need to pass in passwords and secrets to authenticate. For instance, when we deploy to Azure, we have to be able to authenticate with Azure. There are also keys and settings and credentials that our application needs just to run, things like connection strings, API keys, and these need to be set during deployment. So all of this stuff should not be in source control. In fact, GitHub will alert you if you accidentally leave a key in source control, right? Because now you're leaking out your secrets to the public or to a lot of people that shouldn't have them. So how do you handle secrets? Now, right out of the box, there are GitHub Secrets. So in GitHub, for each repository, there's a place to securely store secrets that can be used in your workflow. Here, we're using it to store the publishing profile for our deploying to our staging site. Now, we have to create the secret out of band, so it's not in your code. It's safely stored in a separate location. Right. So to set this up, it's easy enough. Again, it's specific for your repository. You go into the settings, secrets, and here you can create a brand new one. Now, if you do this, you'll notice that there's no way to view these secrets once you stored them. You store them, they're encrypted, and now no human being will ever be able to look at them again. And even if you use them in your GitHub Actions, GitHub does its best to strip them from all the log files, so you still won't be able to see them. But as good as this is, there are some limitations. The secrets might be used in a number of places. So if they're changed, now you're going to need to change it in every single repository that uses this secret. And the key here is you got to remember where they all are. So this is particularly important in the case of an emergency or a security incident where you need to kill all your creds immediately and quickly recycle all of your secrets, right? Trying to remember where every place that uses them, that's really difficult. If you don't remember every repo, deployments are going to break, right? So it's also generally a good practice to cycle your credentials often. So now the person in charge of controlling these credentials, they also need access to every repo that uses them. So if this is your ops team, you can see this does not scale well at all. In fact, it scales pretty badly. So another great way to store your secrets, and not just your secrets, but your keys and certifications as well, is in something called Azure Key Vault. This can be integrated with your other Azure resources, giving us a central place to manage everything. So Azure Key Vault allows you to have a single point of control. And it's also managed by Azure Active Directory. So sensitive information is centralized, and it's managed by the appropriate people. And the workflow simply pulls these credentials just before they need them, and is using another Azure credential that can be controlled centrally as well. So let's take a look at what this looked like. Here's our workflow that uses Key Vault action from Azure to retrieve the Docker password from a specific Key Vault. It's stored in the output variable with the ID KV secret action. And then in the next step, we use that stored secret with the Azure Docker login task to log into Docker. So if we need to cycle our secrets, all we need to do is make those changes to our secrets in Key Vault. We don't need to make any changes to the workflows or in any of our repositories. They will just work. They will just pull those secrets down and everything flat out works. All right, so let's take a look at this in action. Again, we'll be using our Tailwind Traders website. So we're going to jump back to our first demo, and just after we changed our workflow to use Docker for our deployment. So what we're going to do, what currently it's doing, it's using a Docker password that's stored in secrets in GitHub. And we want to change that by pulling these from Key Vault versus using it directly from GitHub Secrets. So to do that, we'll add a couple of actions here. The first, we're going to go ahead and log into Azure, and we'll use the credentials that are specific to this application. So if they need to be reset, we can just reset it for this specific application. After logging into Azure, we want to get the Docker password from Key Vault. So we'll use the Azure Get Key Vault Secrets action. And finally, in our Docker login, instead of using the Docker password from GitHub Secrets, we'll use the secret from Key Vault by referencing the output variable in Docker password. So again, we're logging into Azure, we're getting the specific secret from Key Vault, and then we'll use that secret, and then nothing else has to change. So let's go ahead and commit this, and we'll push those changes back up to GitHub. Okay, so once those changes hit GitHub, it's again going to kick off this action using this specific workflow, right? So this right here is Key Vault. You can see we have our Docker password, and we can also see that this is a place that you can store your secrets and also your keys. Now, it turns out I don't have any secrets or keys or certificates, but if you had some, you would store them here, right? All right, so we have no keys, we have no certificates, but we do have that one secret. All right, now jumping back into action, we can see that our action has kicked off and our workflow is now being triggered. Now, if we jump into this workflow, we can see that it's running. And again, it's not doing anything magic here, but this time, instead of getting our secrets from secrets in GitHub, it's pulling the secrets down from Azure Key Vault, and then it's going to go ahead and use it. So we've seen some pretty cool things with GitHub Actions and Microsoft Teams and Azure App Services all working together to enable us to deliver change to our customers. But we can do so much more too, and our imagination is really the limit here. So we can do all sorts of stuff in our automation tools. So for instance, maybe we want to rotate the credentials in Key Vault for our app. And maybe we want to do this when an admin just asks the team bot to do it. Guess what? We can do that using integrations with Teams to hit the Azure API, rotate the credentials. And the next time we deploy our app, guess what? Everything just works because our workflows pull these secrets down from Key Vault. Maybe we want to automatically build a new developer environment and fork a repository into their private repository based on a properly formatted issue in GitHub Issues, right? So this isn't something that I'm just making up. I've actually seen this happen. So there are people where if you create an issue in a specific private repo, it will automatically create all of your resources up in Azure using ARM templates, and then it will fork that repo into your own personal account. So now you're ready to make changes and fix this particular issue. All right, we can also do things like pull the commit messages since the last production release, so we can automatically build release notes, right? So our imagination is a limit here. With Actions, we can have workflows that automate just about anything inside of GitHub. There's also a repository dispatch event that can be used for any external application. So if you registered this correctly, any external app can now fire repository events to GitHub, triggering your actions. So we've covered a lot of stuff here. So to summarize, add CD to your pipeline, whether it's continuous delivery or ideally continuous deployment. I think it's important to continuously deploy somewhere. It doesn't have to be production, but continuously deploy to a test environment is super valuable. It means not only have you built your app and your tests passed, but you also know your app will deploy successfully. And moving to production will probably work because you've already done this in your test environments. And if you use containers, you can feel even more confident things will just work. Ultimately, though, it's about protecting production. You don't want to deploy all your changes directly to production, and one way to do that is using ChatOps. By using Microsoft Teams and its integration points, you can send adaptive cards that will allow people to do work of promoting changes to make sure the changes are working. And finally, I think it's really important to centralize your secret storage like using Azure Key Vault. Yes, you can put your secrets directly into GitHub Secrets, and you absolutely just don't want to put it in source control. That's the key. But putting all of your secrets in Key Vault, that means you can manage them in a much cleaner way. And if you want to learn more about what we've talked about today in this session, go here and do this Learn Path, which will teach you how to author automations using GitHub Actions. Similarly, if you want to learn how to collaborate with teams and you want to learn how to do that, here's another great Learn Path that does that as well. So go ahead and check that out. Also, there are plenty of documents on Microsoft Docs, so go here to see all the docs about the Teams integration and writing those Teams integration. And if you want to learn about Azure Key Vault, jump in here, and there's all sorts of docs and Learn modules about Key Vault. And finally, thank you all so much for joining me. Hopefully you learned some great DevOps information, and stick around to the next session because we're going to do even more cool DevOps. Thank you.